All right, welcome class. So I wanted to make sure you guys were aware of how to use the serial communicator built into the Arduino IDE in order to effectively debug your Arduino code. So remember when we wrote C++ code, we had the benefit of the debugger that we were using within Visual Studio Code, whereas now on Arduino, we've kind of lost that. So I want to show you guys how to get it back, but slightly different. So one of the things that we could always do even when we didn't use the debuggers, we could always print things to the screen, to the terminal. And if you have your Arduino, matter of fact, a few prerequisites, let's make sure Arduino's connected on the right port with the right board. So always gonna make sure, so my Arduino is already connected via USB, and my board is set to Arduino Mega, and then my port for my computer just showed up as COM7, but it says Arduino Mega there. So that's already done. You wanna make sure you do that first. And what we're going to use is we're going to use what's called serial communication. And actually on the Arduino website, arduino.cc, if you go under resources and reference, I actually have this linked on Canvas, but this is a really good resource for anything Arduino. And so if you scroll down, you'll see communication, and there's serial, and there's also stream. So we're going to talk about serial. And notice that it is a capital S. And so this gets into some details of the serial pins, which we're not going to talk about because we're using USB for the serial communication. But down here, you'll see all the various serial functions. So you can use serial to both read and write information, and how will you communicate with your Arduino. What we're really going to focus on is we're going to focus on printing, right? And so this print function, and we see here that serial is a function. So it's serial.print. And it takes either one or two arguments. If you only do one argument, you can either do a number, so that means a decimal number. You can also do a float number. You also can do a character, which is with the single quotations, and you also can do text strings. So it's very similar to how we've used cout. You also can use it with a second argument, where the second argument is the base or the format. And so you can actually print 78 in binary format, as well as octal format, decimal format, hex format. You also can use the format to limit the number of characters that are displayed for float values. So if I say print 1.23456 and I put 0, it'll only just give me 1 because it says I only want to use one decimal place. And so let's show you guys how to do this. There also are some examples here. And one of the things you'll see in all the examples is this one line of code here, serial.begin. And what that does is it opens the serial port and begins to connect at a certain baud rate. And so the baud rate is very common, is 9600 BPS. So we're going to use that as our default. And so I'm going to just copy that and put that right in my Arduino code. So it needs to go in my setup because it's only going to run once. And so here we go. Serial.begin, which is a function. I need to have my parentheses and put the argument, which is the baud rate. So that's all I need in my setup. And of course, if you're doing this for real, you'd have other things in the setup, but that's all we need for our serial communication. And so inside our loop, I'm going to put my spaces so I can have consistent formatting here. What I need to do is call that serial.print function. So serial, and you'll see as I complete the word, it turns red, lets me know that maybe this is a legit function. And I'm going to call print. Print is my function. And what do I want to print? Let's keep it classic, and I'll go hello world, right? Hello world. So that's it. So if I were to, one thing I noticed some students didn't realize, these two options here, this first one compiles a sketch. It's called verify. The second one uploads the sketch. But when you click upload, it also verifies the sketch. So because I've only written 2 lines and I know they're properly formatted, I'm going to just skip to upload. Okay, it wants to save it. Yeah, let's save that. And then it's going to go ahead and compile. So I see down here that it's compiling the sketch. And the convenience of using the second option there is when it finished compiling, it's going to go ahead and upload it all in one step without me having to wait till it compiles and then upload it. So now it is done uploading. So what I'm going to do now is, now this code is running. It's already running. It's already doing its thing, but we don't see anything yet. And we don't see that yet because we have to open our serial monitor. So go back up to tools here and we'll go down and we want to find our serial monitor. So this is our serial monitor, and there we go. There's our messages. We see hello world all over and over and over again. And what we'll see here is just moving, right? And we can get it to stop by unselecting this auto scroll. And what we'll see is it says hello world. And because I didn't do a carriage return, it keeps putting it all on one line. So all this code is all on one line, printing hello world over and over and over again. And if I want to clear that, I can clear it, but guess what? It's going to start filling right back up over again. So clear it again. And it's happening so fast because one of the things I didn't do is I didn't put a pause in here, right? I didn't put a delay. And so because of that, it's writing it as fast as it can possibly write it to the screen. Now, one thing you'll notice is that the baud rate here needs to match the baud rate you use in your code. But you also can make faster baud rates. So you can go super duper duper fast. However, 9600 is a really good one, and there's generally not a lot of justifications for changing it. And so I'd recommend you just start at 9600. And if you have issues with communication, then maybe you can consider changing it. But there are not a lot of cases that we will explore within our class that would cause us to be able to need to do that. All right, so let's fix this. So I don't have a carriage return. So this is not, we're not cout, we don't have inline, but we can do \n, which is the same as a carriage return. And so if I do this, then what should happen is I should see all those values, and they should be each a row at a time. So if I open the serial monitor again, now I see it. All right, there we go. Perfect, perfect. All right, so we can stop the auto scroll, but it's still generating data. It's just not scrolling. So you can see this starting to fill up here. And I can clear, and it'll start right over and do it again. All right, so that is the basic of how we use our serial monitor. Now, if I had data that was changing over time and I wanted to display the update of that data. So here's an example. I have an integer, and I'm going to call it duty. Let's say we're using it to control our motor, and I'm going to initialize it to 0. And inside my loop, I am updating that duty such that the duty is going to be plus equal 1, which means that every time through the loop, it's going to increase the duty by 1. And I want to actually print out the duty cycle of the motor. And what I'm going to do is I'm actually going to say duty semicolon, colon, put a space here. So that way I'll have room to put the next value. And I don't want to do the inline yet because I actually want to do serial.print. And actually I'm going to do a shortcut here. If I do print is a standard function, but I also can use print line. So it's print ln, and the only difference between print line and print is that print line automatically adds a carriage return. So I don't actually have to add it myself. And so what I want to do is I want to do print line. I actually want to print that integer value. So what this will do is it will print the prompt, which is duty, the label, with the colon, a space, and then it'll print the value of duty, and then it will repeat. So because I don't want this to go super duper fast, I'm actually going to add a delay, and I'm going to go for 1 second. So that would be a delay 1,000. Because there always will be a delay between when your code begins to run and when the serial monitor comes up. Actually, let's see. I'll open the serial monitor now, and I'll also go and compile and run the sketch. So it may take a while. All right, there we go. So duty 2, 3, 4, 5. So every second it's going to display this update. And so this could be very valuable for your code as you're working on the lab for this week, where you're doing exactly the same thing. If you're ever having issues where you're not seeing the results that you're expecting, you can use this serial monitor to display the output of what's happening with your code and your Arduino as you're doing it. So this is always one way to work at debugging your Arduino code. The other way is to actually look at the signals that are coming out of your Arduino. And so we can do that with some tools we're going to get into in the next couple weeks. So using either the oscilloscope as well as using the digital multimeter. So that's all I have for you guys this evening. Hopefully this was pretty efficient and hopefully helpful to help you guys to debug your code. Best of luck, and feel free to reach out if you have any questions getting this all figured out.